The ground shook as 30 engines ignited beneath the N-1 moon rocket. Flames erupted, metal screamed, and the Soviet Union held its breath as history tried to lift itself off the launch pad. This was the rocket meant to beat America to the moon. Instead, it became one of the most violent experiments ever attempted. Built in total secrecy, the N-1 carried the pride of an entire superpower. Engineers pushed untested systems beyond their limits under impossible deadlines. Every launch was a gamble with catastrophic consequences. This is the story of the Soviet moon rocket that almost changed history. The N-1 moon rocket was born from desperation. The Soviet Union had fallen behind in the race to the moon. American Saturn V rockets were already being tested. Political pressure demanded a rapid response. Engineers were ordered to deliver a lunar launch system at any cost. Unlike its American counterpart, the N-1 was developed in secrecy. Competing design bureaus were isolated from one another. Information was tightly controlled and rarely shared. Failures were hidden rather than analyzed openly. This secrecy crippled collaboration from the start. The rocket's design was radical and risky. 30 and K-15 engines were clustered in its first stage. No single engine had enough thrust for liftoff. Complex control systems were required to manage simultaneous ignition and shutdown. This introduced enormous technical risk. Testing philosophy further worsened the situation. Full-scale ground tests were never completed. Engineers relied heavily on simulations and partial data. Problems were often discovered only during launch. Each test flight doubled as a live experiment. Political timelines overruled engineering caution. Launch dates were set before systems were proven. Delays were seen as unacceptable failures. Engineers worked under extreme stress and limited resources. Safety margins were sacrificed for speed. Despite the risks, belief in the N-1 remained strong. Soviet leadership viewed it as the key to lunar victory. Engineers hoped innovation would overcome shortcomings. Every launch carried the weight of national pride. Failure was not considered an option. The first launch of the N-1 took place in February 1969. Engineers watched nervously as all 30 engines ignited. Seconds after liftoff, vibrations began to cascade through the structure. Sensors detected abnormal behavior almost immediately. Control systems struggled to compensate. Less than a minute into flight, the rocket lost stability. Engines shut down unpredictably as the control system attempted to correct thrust imbalance. The massive vehicle began to tumble. Moments later, the N-1 disintegrated in midair. Debris rained down across the steppe. The second launch was even more catastrophic. Shortly after liftoff, a loose bolt was sucked into a turbopump. An engine exploded instantly, triggering a chain reaction. The control system shut down all engines simultaneously. The fully fueled rocket fell back onto the launch pad. The resulting explosion was one of the largest non-nuclear blasts ever recorded. The launch complex was completely destroyed. Shockwaves shattered windows miles away. Engineers survived only because they were located far from the pad. The Soviet moon program suffered a devastating blow. Despite these disasters, the program continued. Engineers attempted to refine engines and control logic. Each fix introduced new unknowns. The complexity of managing 30 engines remained unresolved. Confidence began to erode inside the program. By 1971, 2 more launch attempts were made. Both failed due to engine and control system issues. None of the N-1 rockets reached orbit. The dream of a Soviet moon landing was slipping away. The failure of the N-1 was rooted in fundamental engineering challenges. Managing 30 engines simultaneously was unprecedented. Each engine introduced vibration, heat, and failure risk. Even minor discrepancies in thrust could destabilize the entire rocket. The control system had to react instantly to cascading problems. This complexity created a fragile launch vehicle. Unlike the Saturn V, the N-1 lacked a single powerful first-stage engine. The Soviet Union did not possess an engine equivalent to the American F-1. Engineers compensated by clustering smaller engines instead. This solution increased redundancy in theory. In practice, it multiplied failure points. One engine failure could trigger a catastrophic chain reaction. Engine control was handled by an automated system called KORD. It monitored engine performance and shut down engines when anomalies occurred. However, KORD often reacted too aggressively. Could shut down healthy engines in response to false signals. This rapidly reduced thrust below survivable levels. The system amplified small problems into fatal ones. Ground testing was another critical weakness. The Soviets never conducted a full static fire test of the entire first stage. Engineers relied on simulations and partial tests instead. Many vibration and resonance issues went undetected. These problems only appeared during actual launches. By then, it was too late to correct them. Secrecy also undermined technical progress. Failures were classified and rarely shared across design teams. Lessons learned from one launch were not always fully applied to the next. Engineers worked in isolation rather than collaboration. This slowed improvement and repeated mistakes. The system punished transparency instead of encouraging it. By contrast, the Saturn V benefited from exhaustive testing. Each stage was fired repeatedly on the ground. Failures were openly analyzed and corrected. American engineers embraced delay over disaster. This difference in philosophy proved decisive. Reliability was built long before launch. Ultimately, the N-1 failed not because of lack of talent. Soviet engineers were highly capable and innovative. They were constrained by politics, secrecy, and time. The rocket was pushed into flight before it was ready. Complexity outpaced control. The moon slipped out of reach. By the early 1970s, the Soviet moon dream was collapsing. Multiple N-1 failures had consumed enormous resources. Confidence within the program was fading rapidly. Political leaders began questioning continued investment. The United States had already landed astronauts on the moon. The strategic urgency was gone. In 1974, the N-1 program was quietly canceled. No public announcement was made. Officially, the rocket had never existed. Engineers were reassigned to other projects without explanation. Launch facilities were dismantled or repurposed. The moon program vanished into silence. Secrecy surrounded every aspect of the cancellation. Failures were classified at the highest level. Even many Soviet engineers were unaware of the full scope of the disasters. Records were hidden or destroyed. The outside world remained largely ignorant. The myth of Soviet lunar parity persisted. Despite cancellation, the N-1 left behind valuable knowledge. Engineers learned painful lessons about engine clustering and control systems. Vibration analysis and structural dynamics became priorities in later programs. These lessons would influence future Soviet rockets. Failure became an unspoken teacher. Progress continued quietly. Some technologies survived in unexpected ways. K-15 engine concepts influenced later designs. Control system research informed automated flight logic. Experience with large structures improved heavy lift engineering. These fragments carried forward the N-1's legacy. Nothing was entirely wasted. For decades, Western analysts speculated about the Soviet moon effort. Without access to data, rumors filled the gaps. Some believed the USSR was closer to success than reality allowed. Only after the Cold War did details emerge. The truth shocked many historians. When the N-1 story finally became public, it reshaped space history. It revealed how close ambition came to catastrophe. The rocket became a symbol of secrecy and overreach. Its failures were as dramatic as its goals were bold. The moon race looked very different in hindsight. The N1 had fought a war no one saw. The N1 moon rocket was built to change history. It carried the ambition of an entire superpower. Engineers attempted to overcome physics through sheer complexity. Politics demanded speed over certainty. Secrecy replaced transparency. The result was a machine that never reached its destiny. Unlike the Saturn V, the N1 never had the chance to prove itself fully. Each launch was both a test and a final exam. There was no margin for learning through failure. When something went wrong, everything went wrong at once. The rocket did not forgive hesitation. Space offered no second chances. The collapse of the N1 marked the end of the Soviet lunar dream. Without a heavy-lift rocket, a moon landing was impossible. Resources shifted toward space stations and Earth orbit missions. Ambition was redirected rather than abandoned. The moon was quietly conceded. History moved on. Yet the N1 should not be remembered only for failure. It represented extraordinary engineering courage. Soviet designers worked with limited tools under immense pressure. They pushed technology beyond proven limits. Many of their ideas were ahead of their time. Failure did not erase innovation. Lessons from the N1 shaped future spaceflight. Engine clustering was approached more cautiously. Ground testing became non-negotiable. Control systems grew more robust and redundant. Transparency proved essential to progress. These lessons echo in modern rockets. Today, the N1 stands as a warning and a testament. A warning about rushing complexity without preparation. A testament to human ambition reaching for the impossible. It reminds us that spaceflight is unforgiving. Every success is built on countless failures. Every launch carries history with it. In the end, the N1 moon rocket never touched the stars. But its story remains deeply human. Tells of pride, pressure, and perseverance. Of engineers racing against time and politics. Of dreams that burned brightly and vanished in flame. And of how close history came to being different.